Good morning, ladies and gentlemen. Welcome to week 5 of your SAT Prep Math Plug Time class sets. Okay, here we're looking at this video is going to be heard by sophomores who are in pre-AP Algebra 2. So ignore the fact that the worksheet you're working on says juniors. Again, we're just trying to make sure that this particular set of information applies to what you've been doing in class. So once again, please make sure that you're putting your name clearly at the top of the paper, first and last name, and that you're getting your teacher's name circled and your class circled. Okay, so we're sticking with systems this week. So let's get right into it here. We're going to have less examples this week. We're also going to practice the entry method. Remember that on the computer you are only going to be allowed to type in 4 total characters in the computer, which means if you decide to put your answer as a decimal, you cannot put 0.7. You would just need to put 0.7. Because if you put the 0 in there, it's going to take up too many things. So we're going to jump in here to example 1. In example 1, we should notice that this is set up for substitution method. The reason we should recognize substitution method is because we have one equation that is already solved for one variable. In this case, x equals 2y minus 3 would indicate that we can take that to negative 2y minus 3 and plug it into the first equation. So that would be negative 5 times, and then that would be where we would plug in negative 2y minus 3, okay, minus 4y equals negative 9. By doing this, what we have done is we have eliminated one of the 2 variables from the equation, allowing us to solve the equation for y, because it's the only variable that remains. So we would distribute the negative 5. That would give us 10y plus 15 minus 4y equals negative 9. Then we would combine like terms. 10y minus 4y would give us 6y plus 15 equals negative 9. And it's a 2-step equation, so we would subtract 15 from each side. That would give us 6y equals negative 24. And then we would divide by 6, which would give us y equals 4. Now once we have negative 4, then we would turn around and solve that for x, which is negative 2y minus 3. So we would plug that negative 4 in for y, would give us 8 minus 3, so x is 5. Okay, then the final step of the process is to actually plug those in to find the value of negative 1/4 xy. Well, that would be negative 1/4 times x, which is 5, times y, which is negative 4. You're welcome to use your calculator to feed those together, but we should recognize that we have 2 negatives, which means our answer is positive. 1/4 times 5 times 4 is 5. So our answer to this question, we would enter one digit, 5. On the old paper pencil, we would have to bubble that in. On the computer, I don't believe you're going to have to do that. So your answer to this question is that negative 1/4 xy is equal to 5. On to example 2. And again, we've been doing systems for several weeks. So we should recognize that example 2, first of all, before we even read the question, we should look at this problem and go, ew, fractions, and we should get rid of the fractions. So the first equation, we need to multiply by the least common denominator of 7. That would get rid of the fractions there. And the second, we should multiply both sides by 6, which is the least common denominator there. When we do that, we are left with 8x minus 7y equals 13 for our new first equation. Notice the fractions are gone. And the second equation would be 1x minus 2y equals negative 4. So both equations are now in standard form, which should indicate that this is an elimination question. Okay, so we should be using the elimination method to solve this system. What I would do is I would multiply the second equation by negative 8. Okay, and I would rewrite the system. So I'm looking at I'm going to move down here. 8x minus 7y equals 13 is my first equation. And negative 8x plus 16y equals 32 is my second equation. I add those two equations together because the entire point of doing that was to make it so that when I added the equations together, the x's would cancel out. That gives me negative 7y plus 16y, which is 9y, equals 13 plus 32 is 45. This one-step equation can be solved for y by dividing each side by 9, which would give me y equals 5. And then we need to turn around and solve for x. So I'm going to plug that back in to 1x minus 2y equals negative 4, which is my second equation from after I eliminated the fractions. You could technically plug it into any of these four, and it should give you the same answer regardless. So that means 1x minus 2 times 5 equals negative 4, or x minus 10 equals negative 4. Add 10 to each side, and we get our x value is 6. So x equals 6. Now, as with most SAT questions, there is another step, and that is we need to find the value of x minus y. So x is 6, y is 5. 6 minus 5 would be 1. So our answer to this question would be 1. Ooh, that was interesting. Not sure why I did that. Okay. So our answer is the value of x minus y, which is 1. Okay. So again, we did this last week. We just did more practice this week. Okay, so ladies and gentlemen, on the back side of your paper, there are more examples of systems of equations for you to try. Okay? And you need to solve these couple of examples and then turn your paper into your proctor. So once again, ladies and gentlemen, thank you very much for your time and attention through this process. Make sure that you show all of your work on the back side of this paper. And when you're done, make sure your name, first and last name is on it, and turn it into your proctor. Thank you very much for your time and attention.